A linear function is any function that graphs to a straight line.
The domain of a linear function is negative infinity, infinity, or all real numbers. The range is also negative infinity, infinity.
This function does not have any discontinuity and is continuous at all x.
The function f of x equals x is also not bounded. It extends to infinity in all directions.
The function has an odd symmetry because it is symmetrical about the origin.
This function increases from negative infinity to positive infinity, so therefore does not decrease anywhere.
Because there is no boundedness, there also is no extrema.
Since f of x equals x is a linear function, there are no asymptotes.
The limit of f of x as x approaches infinity is infinity. The limit of f of x as x approaches negative infinity is negative infinity.
A quadratic function is one of a form f of x equals ax squared plus bx plus c. The graph is shaped in a curve called a parabola.
The domain is negative infinity, infinity, or all real numbers. The range of a standard graph is 0, infinity.
A quadratic function is continuous at all x. It is bounded below with a minimum of 0, 0.
It has an even symmetry, meaning the graph can be reflected across the y-axis.
The graph decreases from negative infinity to 0 and increases from 0 to infinity.
It has an absolute minimum of 0 at x equals 0.
There is no vertical or horizontal asymptote.
The limit of f of x as x approaches infinity is infinity, and the limit of f of x as x approaches negative infinity is also infinity.
This is a cubic function. The cubic function will always have an x value cubed. We will now analyze the parent function.
The domain is all real numbers. The range is also all real numbers. The continuity is continuous at all x values. The function is not bounded. Its symmetry is odd.
The function is not decreasing, and it is increasing at infinity to infinity. At negative infinity to infinity. There are no extrema values. No vertical asymptote, no vertical asymptote, no horizontal asymptote, and its end behavior is as x values approach both positive infinity and negative infinity, or positive infinity and negative infinity, respectively.
This is a rational function. We will now analyze the parent function. The domain is negative infinity to 0 and 0 to infinity. The range is also negative infinity to 0 and 0 to infinity. And continuity is a non-removable infinite at 0. The function is not bounded and has odd symmetry.
The function is decreasing from negative infinity to 0 to infinity, and it isn't increasing. There are no extreme values, there is no vertical asymptote, and the horizontal asymptote is x equals 0. The x equals 0. The horizontal asymptote is y equals 0. The end behavior is as x approaches negative infinity. Y value gets closer to 0 as well when approaching infinity.
Okay. We had a square root function. The domain and range of a square root function are all real numbers greater than equal to 0, and there is no discontinuity.
A square root function is bounded below. There's no symmetry, even or odd, and it doesn't decrease.
The graph is increasing at 0, infinity. There are no asymptotes.
The extrema of the function can be described by saying that there's an absolute minimum of 0 at x is equal to 0, and finally the end behavior can be described by saying that there's a limit of f of x as x approaches infinity, and that is equal to infinity.
The domain of the function f of x equals e to the x is negative infinity to positive infinity. The range is 0 to infinity. The continuity is continuous. It is bounded below. It has no symmetry and is not decreasing.
This function is increasing from 0 to infinity. There's no extrema. There's no vertical asymptote, and the horizontal asymptote is 0. The end behavior is limit f of x equals infinity, x to the infinity. Limit f of x equals 0, x to negative infinity.
F of x equals the natural log of x is the parent function for natural logarithm functions. The domain of the function is 0 to infinity. This is because our line of equations starts at 0 but not touching and goes on endlessly. The range of the function is negative infinity to infinity because the function never touches any negative y coordinate since it has a vertical asymptote. Since it also doesn't have any holes or horizontal asymptotes, it continues on indefinitely throughout the positive y coordinates on the graph.
The function has a non-removable infinite discontinuity at x equals 0 because the function has a vertical asymptote of x equals 0 and its lines go on infinitely. The function is not bounded because its lines are vertically ongoing. The function has no symmetry because plugging in negative x to the original equation makes it neither even nor odd.
The function doesn't decrease at all as it has a vertical asymptote of x equals 0. It does, however, increase beginning at 0 and continuing on indefinitely. An extrema for this equation doesn't exist as it isn't bounded.
The vertical asymptote is x equals 0 because the line never touches the y-axis. There is no horizontal asymptote because the line stretches infinitely up and down. The limit of f of x as x approaches infinity is infinity. There is no limit as f of x approaches negative infinity.
This is a sine function. The domain of this function is negative infinity to infinity or all real numbers. The range is -1 to 1. The continuity is continuous because you can draw the graph without even lifting your pencil. The boundedness is bounded. The symmetry is odd because it can't reflect evenly over the y-axis.
The function is decreasing and increasing. It's oscillating as it goes because it increases and decreases forever. The extrema is absolute max 1 at x pi divided by 2 plus 2 pi k. And absolute min of -1 at x equals 3 pi over 2 plus 2 pi k. We'll learn that more in Unit 4. And then the vertical and horizontal asymptote, there is none. And the end behavior is it does not exist for the negative infinity and the infinity.
We had cosine function. The domain is negative infinity to infinity. The range is -1 to 1. The continuity is continuous. Its boundness is bounded. And symmetry is even. It's decreasing and increasing and oscillating for it's going up and down.
The extrema is the absolute max of 1 at x equals 0 plus 2 pi k. The absolute min of -1 at x equals pi plus 2 pi k. There is no vertical asymptote. There's also no horizontal asymptote, and there is no end behavior because it does not approach anything related to perfect.
The domain is all the x values on the graph of the equation. For f of x equals absolute value of x, the domain is negative infinity to positive infinity. The range is all y values on the graph of the equation. Ours is bracket 0, infinity, because the point 0, 0 is the lowest. So we have to use the bracket because it's equal to. For continuity, our equation has no holes, gaps, or jumps, meaning it is continuous. For boundedness, our equation never goes below y equals 0, so it is bounded below. And for symmetry, for our equation, it's x equals 0, and it is even.
It's decreasing from negative infinity to 0. It's increasing from 0 to infinity. There's an absolute minimum at 0. There are no asymptotes, and as x approaches infinity, y approaches infinity, and as x approaches negative infinity, y approaches negative infinity.
This is a greatest integer function. It can also be called a step or force function. But before I start analyzing the function, I'm going to show you how to put it in your calculator. So if you put it in with just the brackets like you see it on your paper, it will give you a line that's just a straight line, and that's not going to be the same thing as what's on your paper. So what you need to do is go to math, over to number, and option number 5, and then type in the equation, and that will give you what you have on your paper. And then another thing to keep in mind is the greatest integer function can be written in either of these two forms, and they both mean the same thing.
The domain is negative infinity to positive infinity, and the range is the set of all integers.
There are no discontinuities.
This function is not bounded.
It is constant on each step, and there are no extrema.
It has no vertical asymptote or horizontal asymptote.
The end behavior for limit of f of x as x approaches infinity is infinity, and the end behavior of f of x as x approaches negative infinity is negative infinity.
This is our logistic function. F of x equals to 1 over 1 plus the natural number to the power of negative x. The domain of this function is from negative infinity to infinity, and as you can see on the graph, the x values go on forever. The range of this function is from 0 to 1, and we use parentheses because the function never touches 1 or 0.
The continuity for this function is continuous. The boundedness of this function is bounded above and below. There is no symmetry because when you flip it over either of the axes, it doesn't match up.
This graph is never decreasing but always increasing, therefore there is no extrema.
There is no vertical asymptotes. There are two horizontal asymptotes at y equals 1 and y equals 0, as you can see on the graph. The limit of f of x as x approaches infinity is 1. The limit of f of x as x approaches negative infinity is 0.